Geometries. We found in the third video in this course that to see an object via the renderer, it's usually a mesh object. There are exceptions to this, such as line segments and particles, but the main visible object you'll see in a Three.JS scene will be a mesh. We also learned that when a new mesh instance is created, it takes a geometry parameter and a material parameter. We'll look at materials in the next video, but in this video we'll focus on the different geometries you can generate just using the library. Later in the course we'll look at using external programs to create meshes, but at this stage we'll look at the ones you can create with just the library code. The geometry classes included with the library are the primitives box, circle, cone, cylinder, dodecahedron, icosahedron, octahedron, plane, sphere, tetrahedron, torus, torus knot, and there are several classes that will construct geometry such as edges, extrude, lathe, parametric, shape, text and tube. All the details for using the primitives are on the website in the documentation section. So rather than going through them all, let's look at just a couple, then move to the construct options, which are more difficult to understand and use. Take a look at Start Lecture 7 for the starting template for this video. It's essentially the same as Lecture 5. The only thing we will change is the geometry used when creating the mesh. Just replace box with circle. If you feel that the circle is too faceted, then just take a look at the documentation to see that a circle buffer geometry instance can take up to 4 parameters. The first is the radius, which defaults to 1, then the number of segments, so entering 132 will give a much smoother circle. If you want a half circle, then enter 0 as the third parameter and math.pi as the fourth. Parameters 3 and 4 give the starting and ending angles when generating a circle. By default the starting angle is 0, which is equivalent of the x-axis, and the default end angle is 2 pi, which is again the x-axis. 2 pi is a full revolution in radians. By setting parameter 4 as just pi, we get a half circle. You might be wondering why the circle disappears as it rotates. By default, only front-facing triangles are rendered by the renderer, so as the circle rotates and shows its rear to the camera, the renderer ignores these faces. Eventually it rotates around enough to start showing the front-facing triangle again. Play around with the different geometries and check the documentation to customize them. Once you've had a play, it's time to think about constructive geometries, and we'll look at the extrude geometry class. This takes a shape instance and extrudes it along the z-axis. The class requires 2 parameters, a shape and a settings object. Comment out the first geometry line and uncomment the other. Notice the call to create star geometry. We need to add some code to this method. That will take some unpicking. First, the shape. A shape instance has move to and line to methods. The idea is to draw a shape in the XY plane. Here we draw a 5-pointed star. We define an inner and outer radius for the star and then set an inc value, which is the angle to move by when drawing each line. To calculate this angle we define a full revolution in radians. Remember that yet? It's pi times 2. Then for each point of the star we're going to need to move around the circle twice. Once to draw from the inner radius to the outer radius, and a second rotate to move from the outer to the inner. Then we move the current point of the shape to outer radius 0. We'll need a variable defining if the next point should use the inner or outer radius. Because we're starting at the outer radius, the next point should be on the inner radius, so we initialize inner to true. Then in a for loop we increment an angle theta until it exceeds 2 pi. In other words, from angle inc up to a complete revolution. We set a radius property alternating between inner and outer radius. Then draw a line to cos theta sine theta times radius. Cos theta sine theta will be on the perimeter of a circle of radius 1. Multiplying these values by the inner and outer radius, we first draw a line from the outer to the inner radius, having rotated by ink. Then we draw a line to the outer radius, having again rotated. Repeating this 10 times, we have a star shape. Then we define a simple extrude settings object, saying we want to span the entire length in a single step and that the depth of the extrusion is 1 unit. We set bevel to false. If you look at the documentation, you can see how bevel would work. It just remains to return an instance of Three.JS Geometry using the shape instance we've created and the extrude settings object. Save and refresh the browser. Now we have a rotating object that has a star-shaped cross-section. Can you write a function that will extrude a hexagon? This is very similar to the create star geometry method. I recommend copying it as a starting point. The main difference is we don't need to keep switching the radius value, and we only need to divide pi2 by 6. How did that go? I know it's tricky, but practice is the best way to learn. I started by copying the create star geometry method and renaming it create polygon geometry. We only need radius, let's default it to 1, and change points to sides, defaulting this to 6. Now switch points times 2 to sides. The ink value will be a full revolution pi times 2 divided by the number of sides in our polygon. The move to just uses radius, and we can delete both the code lines in the for loop that deal with switching the radius value. Lastly, we'll make the depth in the extrude settings a quarter of the radius, and that's it for the method. Back in the constructor, add a call to this new method. Save, refresh the browser, and there's an extruded hexagon rotating. Nice! Go ahead and play with the other ways you can construct geometry using Three.JS classes. Here's a default icosahedron, save and refresh, a default torus, save and refresh, and a default torus knot, save and refresh. In this video you've learnt about Three.JS's geometry classes and also how to build geometry using the classes shape and extrude geometry. When you're ready, it's time to play around with materials. See you in a minute.